I'm standing 100 metres below the ground at CERN in Geneva, and this is the CMS detector, part of the largest and most complicated scientific experiment ever attempted. Here, we'll recreate the conditions that were present in the universe less than a billionth of a second after the Big Bang. How do we recreate those extreme conditions here on Earth? Well, you need one of these, the Large Hadron Collider. 27 kilometres in circumference and filled with over 2,000 superconducting magnets, each at 1.9 Kelvin. That means that they're colder than the space between the stars. Inside here, we accelerate protons to 99.999999% the speed of light before bringing them into collision inside 4 giant detectors. And those detectors take pictures of the collisions 600 million times a second. These are the lengths we have to go to discover the fundamental building blocks of the universe. Why would we build all this to understand the universe? The universe today seems almost impossibly complex, full of planets, stars, and even life itself. But over centuries of experimentation, we've found that the complexity is really a property of an old, cold universe. When the universe was much younger and much hotter, it appeared to be much simpler. And so it's here that we're going to recreate the conditions that were present in the very earliest times to hopefully reveal that underlying simplicity.
Well, speaking as a cosmologist, the LHC will be exciting because it should say yes or no to whether the Higgs boson, a type of particle, exists or not. And it's a sort of particle that cosmologists are interested in because we think particles of that type are responsible for a very rapid expansion of the universe in its early history, which forms the cornerstone of modern cosmology. It's a theory called inflation.
The standard model, our theory of particle physics that we have, tells us that there should be a Higgs and we should find it without trouble at the LHC. But our theory could be wrong. We know that our theory is incomplete, which means it has to break down somewhere. So if we don't find a Higgs at the LHC, it could be a sign that a new, deeper, underlying theory of matter is just about to surface.
When you go to a new regime like the LHC will, quite often something pops up that's unexpected and can take physics down a different path altogether. And that's the sort of exciting physics that I'd like to see at the LHC.
Well, the LHC could find that there turn out to be more than 3 dimensions of space and 1 of time, and particles can actually disappear into extra dimensions, which is pretty wild and wacky, but it could be real science and not science fiction at the LHC.
I wouldn't like to predict what will happen at the LHC. It's like guessing what we'll find on our first journey to the stars. But the giants of history would have loved access to this machine because science is about exploring, and the only way to uncover the secrets of the universe is to go and look.